So, good day everyone. We are the group 9. So, we are assigned to report the radar plotting. So, I'm Jordan Sumalpong. So, I'm the first reporter. Next, pre. So, the ILO or intended learning outcome. At the end of this lesson, the students are able to 1. Define plotting. 2. Determine kinds of plotting. 3. Explain the relationship between speed, time, and distance. 4. Characterize collision avoidance methods. Next, pre. So, plotting. Plotting is the graphic displaying of an encounter between observer or own ship and one or more other vessels or the targets, all within radar range of each other. Plotting will be done on radar plotting sheet or on reflection plotter made of plastic or glass. Primarily, it is done to determine if risk of collision exists. Secondly, where it is found that such risk exists, it is used in an effort to determine the proper and sensible actions which could be taken to avoid casualty. Next one. So, radar motion display. So, actual or true motion is expressed in terms of direction and rate of movement or speed relative to the earth. So, this is an example of radar motion display. Next, pre. So, relative motion are also expressed in terms of direction and rate of movement of one moving vehicle to another object. The lat- latter being either stationary or moving, it is the combined effect or apparent result of viewing one moving vehicle against another object. Subconsciously, we estimate the apparent speed and direction of the pedestrians or vehicles, direction of relative motion and speed of relative motion, and adjust our own true direction and actual rate of travel to avoid collision. Next, pre. So, relative motion between two ships. So, this is the example. B bears 104 degrees. The distance is 5.5 miles. The second, the A2, bears 134 degrees. The distance is 3.8 miles. The A1 bears 180 degrees. The distance is 4 miles. So the B3 bears 284 degrees. The distance is 5.5 miles. So the B2 bears 314 degrees. The distance is 3.8 miles. The B1 bears 00 degrees. The distance is 4 miles. Next, play. Kinds of plotting. 1. Manual plotting is done manually. Two main subdivisions. A. Transfer plotting. Radar information and transferred to a maneuvering board sheets or radar plotting sheet. B. Direct plotting, done right on a special plastic or glass surface over the PPI, or provided the radar set has a reflection plotter, using grease pencil to construct the plot. Next. So this is the plotting sheet, radar transfer plotting sheet. So next, bro. So the next reporter, Gitwayan, will continue the report.
So to continue this report, so I'm the Cadet Gitwain. So number 2, automatic plotting is accomplished by self-acting digital data processing equipment which is interface with the radar and provides audible and visual threat detection, graphic display or plot, and readouts of the parameters of the problems such as CPA contacts, true course contacts, actual speed. Two major types. One, automated system. Use computer to process the raw data. Two, image retention system. Use either high resistance video or electronic device such as video recorders and playback. These systems have the capacity to retain past position of contacts. So this is the example. Explain. So relative radar plotting symbols and the vector triangle. So OC or own course, true course, speed of own shape, OS is also noted. E, point of origin, the own shape vector and the triangle vector. R is target shapes, first observation, initial position of the contact. This is pointed by the true bearing, range, and time of observation. If relative bearing is taken, change to true bearing. Display. M is the target of the shape designation. Targets, true bearing, range, and time. The end of target's relative movement in the first vector triangle. The end of true target's course vector triangle. RML or relative motion line. Line connecting to M. This is the target's relative movement in relation to own shape. This is not the true course of the target. DRM or direction of the relative motion line. Always in the direction of R to M can be found by transferring to RML to the center and the corresponding degrees. CPA or closest point of approach. The point where the target will be at its nearest distance to own shape. Bearing of CPA is the true bearing when the target is at CPA. This is perpendicular to the RML from the center. This can be computed by adding or subtracting 90 degrees to the DRML. CPA or time at CPA. In CPA or new closest point of approach, this is the desired distance the own ship wants to clear the target. SRM or relative speed of the target. control speed. This is the rate or speed at which the contact closest to own ship, SM, or actual target's cruise speed. This can be computed measuring by the scale, the magnitude or length, the vector E to M, and apply the time interval between R to M, CM or true course to target. This is found by the transferring the E to M to the center and reading the corresponding degrees and their direction. NRML or New Relative Motion Line. After deciding on the desired new closest point of approach or NCPA or the radius of the desired danger circle, draw a line from the point execution or MX tangent to the NCPA. MX means point of execution. Additional vector triangle. After establishing the ERM vector triangle and deciding the point of execution or MX, also the desired passing distance of the target or NCPA, though the NRML and own ship will decide the course and action take and method to be employed for the collision avoidance. For these solutions, additional triangle vector diagram is plotted as follows: ARM vector triangle.
So I'm glad one new continuation of our board. So P-R1 shows direction and speed of own ship to avoid collision. Transfer the line to the center will show the corresponding true course of own ship. R1 minus M dash M shows the new relative direction and speed the target ship. Transfer the line to the center to show the corresponding degrees for
Pidahin mo na kwanta nun,
direction
Bal.
of
Dala itong
NRML.
pinakaunan mo.
AC collision avoidance force. AS collision avoidance speed.
Ilakad lang?
ROCS assume on ship course and speed. The vector triangle diagram. Speed vector or speed triangle. The speed vector are vectors of motion taking place. We have two properties. One, direction
Kutot
of
dahil.
motion,
Lapas ay.
and number two, speed of motion. The vector triangle is made of 6 factors. So OC,
Hingga.
direction from E to R. OS,
Yahay, kay hinggo.
length from E to R.
Wala pang may balanse.
CM,
Tingnan, bra.
direction from E to M. SM,
Ba't
length from
nagkakabutot?
E to M.
Abot
DRM,
mo ka, kuan,
direction
trace ka
from
ron.
R to M. SRM, length from R to M.
Tangkaloy mo na, no?
The
Pila po na?
target angle or tan is a relative bearing measured
Dito,
from
dito po
CM
sa,
to
kana,
TPO,
kita na.
either
Muha na.
port or starboard.
Muloy ano mo?
0 to 180 degrees. TAS is red if TPO is on the port side of the contact. TAS is green if TPO is on the starboard side of the contact. Rule of flipping the TAS: if TAN is less than 180 degrees, then TAS is
Layo po mo
equal
dire.
to TAN, naming it green. And if TAN is more than 180 degrees, then TAS is equal to 360 degrees minus TAN, naming it red.
Pag naaring mo sa'yo, dre.
So this is the example.
Daog po mo pirme.
That's all.